Since we've already learnt the special products rules, factorising using them is pretty straightforward. You just go opposite from expanding. So just remember that the difference of two squares rule, before I was looking at the two brackets and going to get rid of the brackets, now I'm just putting them back in again. So I'm looking at something that is a squared minus from another squared, and therefore I can factorise it and put it straight into a plus b, a minus b, whatever my variables are. And then if I'm looking at the perfect square rule, that's my other special product, then I'm looking for it to look like a squared minus 2 lots of a times b plus b squared, or a squared plus 2ab plus b squared. And then what is that going to give me when I factorise it? I'm just going to have a minus b all squared. Remember, that's only because there is a minus in front of my 2ab, and then I'm going to have a plus b squared when there's a plus in front of my 2ab. So pretty straightforward there. So those are my only two rules that I'm dealing with. Okay, so let's cover a couple of quick examples. What about if I have, let's see. Well, since I've already told you that I'm using the difference of two squares, I know that these are two squares, but the numbers are not quite right. So the first thing you really want to do is see if there's a highest common factor. And the highest common factor here is going to be 2. If I divide both those numbers by 2, I'm going to get much nicer numbers that are squares. So if I divide 72 by 2, I'm obviously going to get 36. If I divide 98 by 2, I'm going to get 49. Now you should be able to tell me that those are the square of two numbers. So technically, really, I've got 6x all squared minus 7y all squared. Now, whatever's inside those last brackets, so in here and in here, those are my two squares. So I can just simply leave the 2 on the outside, and I'm going to have 6x minus my second term and first term plus second term. That's how you factorise dots. Very straightforward. Okay, so the immediate reaction for us to do is to factorise by simplifying first and then do the factorisation. But if we actually look at this closely, this is a squared number and this is a squared number, and I've got a difference in the middle. So that means I can factorise those two using dots. So I've actually got 12p, right, because 140 is 12 squared, minus 7r, 12p plus 7r. Okay, and then I can look at my second one over here and go, do I have something in common between those two? Well, yeah, I do. It's q, right? So I've got q in there and q here. So I'm going to take out the q. If I take out just the q, let's see what happens. So I've got 7q, and then I have minus 12p plus 7r. Now you should be able to tell me that it's very similar to one of the things we have, but it's not quite the same because I've got a minus here and I don't have a minus 12p in any of these. So what happens if I then times everything here at the back by negative 1? I'll get 12p, leave the same at the front, right? 12p plus 7r. And then I'm going to have minus q, and all the signs change. So I've got plus 12p minus 7r. Now, you should be able to say, well, actually, that's a binomial factor with that, right? So that can come to the front. And I've got 12p minus 7r. Now, this one you need to look at like a grouping. It's a confusing grouping, but it is there. This was multiplying itself by this and this. So what goes in the second bracket is 12p plus 7r minus q. Okay, and if there were any like terms, this would be then when you simplify it inside the bracket. So if I did have anything like in here, I'm going to simplify it, same goes here, but I don't, so I'm going to leave it as is, and that's your fully factorised. And I know that it's fully factorised because it is a product of factors. So binomial factor, this was the factors that was left from this multiplication, right? when I factorised this. And when I started factorising this and took the highest common factor out, well, I've taken out a factor, and that factor goes here. Okay, so now we've looked at dots. Okay, so perfect square rule, perfect square method just means that I'm looking for the three terms, and therefore can I then factorise those three terms into an a plus b all squared or an a minus b all squared. So if I've got a squared number at the beginning and a squared number at the end, then and it's three terms, then all I need to figure out then is that middle term 2 times the square root of my first term and last term. If it is, then I know that I've got a perfect square, and I can go immediately to factorising it using my perfect square method. So here's an example. Let's have a look at it and say, well, do I have two squared numbers? First thing you need to look at is, do I have a squared number at the beginning and do I have a squared number at the end? Doesn't really matter about the middle term for now, but I just want to check if those two rules conform. If that doesn't conform, then you already know it's not a perfect square. But if they do, then you can then reassess the middle term and see if it conforms to the last two multiplied by each other times 2, right? So let's have a look. That first term is 25x squared. 25 is the square of 5, and x squared is the square of x. So I know that that's actually 5x squared. Now, in the middle, let's not worry about it. Let's look at the last term. 1 is the square of 1, so that's fine. I've just got 1 squared. If that was a minus at the end, so it was minus 1, so I had two squares, but one was a negative at the end, or negative at the beginning, then it's not perfect square, unless you could possibly take out a highest common factor. There's no highest common factor in this one, so we don't need to worry about it. But if there was, that's where you need to look for first, and then the squares will hopefully become apparent to you if it is the perfect square rule. Okay, so now I'll look at the middle and I say, well, is that 2 times what I've got in my brackets now? So I've got 5 and 1. Is this 2 times 5 times 1? So 5 times 1 is 5, times 2 is 10. And the x, yes, okay, so I know that that actually is 2 times 5x times 1. That means that it conforms to a squared minus 2ab plus b squared, which is the perfect square, right? So therefore, I can immediately put it into the form of a minus b all squared, where a is 5x and b is 1. And then I could just expand it to try it. That's basically all you're doing when you're using the perfect square rule. The only difference might be that you have highest common factor, or that is then coupled with something else, like with our example for the difference of two square rules. So you might look at an example and have other things on the end here and go, well, actually, no, I need to factorise that first. Okay, so that's it for our special methods. So all you need to do now is, if you want to practice, please have a look at exercise 2.4. You can also do the chapter review, or you can do a practice test.